Hello viewers, hope you are doing well. Today our topic is about drilling mud properties. Before starting that, subscribe the channel and press the bell icon to get more updates. So, drilling mud properties. The properties of a drilling fluid can be analyzed by its physical and chemical attributes. The major properties of the fluid should be measured and reported daily in the drilling morning report. Each mud property contributes to the character of the fluid and must be monitored regularly to show trends, which can be used to ascertain what is happening to the mud whilst drilling. There are many tests a fluid can have. The major ones are explained below. First is mud weight or mud density. Unit. The unit of mud weight or mud density is pounds per gallon or ppg. Apparatus. Mud balance, or where gases may be entrapped in the mud due to high weights or thick mud, then a pressure balance should be used. Each should be calibrated at the start of the job to weigh 8.33 ppg with fresh water. As shown in the figure, a cup is filled with a sample of mud and is then balanced on the mud balance, which is calibrated to read mud weight directly. Second is funnel viscosity. Unit. The unit of funnel viscosity is seconds per quart. Alternatives. Seconds per liter. 1 quart equals 0.946 liter. Apparatus. Marsh funnel. In use, the funnel is held vertically with the end of the tube closed by a finger. The liquid to be measured is poured through the mesh to remove any particles which might block the tube. When the fluid level reaches the mesh, the amount inside is equal to the rated volume. To take the measurement, the finger is released as a stop clock is started, and the liquid is allowed to run into a measuring container. The time in seconds is recorded as a measure of the viscosity. This is usually calibrated to read 26 plus or minus 0.5 seconds when testing with fresh water. Mu equals rho T25, where mu equals effective viscosity in centipoise. Rho equals density in gram per centimeter cube. T equals quart funnel time in seconds. As given in the figure. The Marsh funnel is a simple device used for the routine monitoring of the viscosity, and should be performed alongside the mud weight check. Marsh funnel readings are affected by mud weight, solids content and temperature. The value from the Marsh funnel should only be used for comparison purposes and for monitoring trends. The following figure is given for Marsh funnel. Third is plastic viscosity PV. Apparatus. Viscometer or rheometer is a device used to measure the viscosity and yield point of mud. A sample of mud is placed in a slurry cup and rotation of a sleeve in the mud gives readings which can be mathematically converted into plastic viscosity and yield 0.6. Multi-speed rheometer are recommended whenever possible since readings can be obtained at 600, 300, 200, 100, 6 and 3 rpm. PV, in CP, is measured by taking the difference between the dial readings taken at the two highest speeds of 600 rpm and 300 rpm. If temperature is a factor, then the mud sample should be tested at 120 Fahrenheit, with the mud in a heating cup. Fourth is yield point. Unit. Pound-foot 100 square foot. Alternatives. Pascals equals pounds 100 square foot multiply 0.48. Apparatus. Same equipment is used for measurement of plastic viscosity. Fifth is gel strengths. Unit. Same as yield point. Alternatives. Same as yield point. Apparatus. 6-speed viscometer. There are two readings for gel strengths, 10 second and 10 minute, with the speed of the viscometer set at 3 rpm. The fluid must have remained static prior to each test, and the highest peak reading will be reported. Applications. The gel strength quantifies the thiotropic behavior of a fluid, its ability to have strength when static, in order to suspend cuttings, and flow when put under enough force. Ideally, the two values of gel strength should be close rather than progressively far apart. Sixth is fluid loss and filter cake. Fluid loss. Unit milliliter per 30 minutes at 100 psi, for API test, or 500 psi and BHTF, for high temperature over high pressure HTHP. Filter cake thickness, 1 by 32 inch. Apparatus. Both tests work on filling a cell with drilling fluid, and sealing it shut. Inside the cell is a filter paper that has been placed between the mud and the aperture in the cell. Pressure is applied to the cell, which forces the mud and solids through the filter paper. The solids accumulating on the filter paper form a filter cake, and the filtrate passing through the paper is collected in a graduated cylinder. The mud in the cell is pressurized for 30 minutes and the fluid or filtrate is collected and measured. The filter paper is also collected, washed, then examined, and the deposited filter cake is measured. HPHT tests with the cell put under heat are usually carried out on wells where the temperature is greater than 200 degrees Fahrenheit. Applications. The fluid loss gives a representation of the fluid's interaction with the well bore under simulated pressure and temperature conditions. Ideally, the fluid should form a thin, flexible, impermeable layer, filter cake, against the wall and prevent fluid, filtrate, from entering the rock and reacting with the formations. A mud system with a low value of filtrate loss causes minimum swelling of clays and minimum formation damage.